All right, now I'm only going to be able to introduce you to this particular study. It's the same one that I describe in the book, but this will hopefully reinforce what you're reading. So let's pretend that you want to know whether or not marijuana and hemispheric dominance have any effect on creativity. So here you're not just looking at one factor anymore, right? Because you have marijuana. Marijuana could have an effect on creativity just by itself, right? In fact, if you speak to people who use marijuana, they will certainly attest that they believe that marijuana makes them really, really, really creative. I'll let you in on a little secret. Objective tests of creativity do not support that. So marijuana users think they are being creative. In reality, that's probably not the case. All right, so marijuana alone could have an influence on creativity, and hemispheric dominance alone could also affect creativity. So here we have our two separate factors, right? So marijuana and hemispheric dominance, left versus right. Now, there's a third possibility, and that is that marijuana and hemispheric dominance could have a combined effect on creativity. And that's the primary advantage of a factorial ANOVA. So unlike single factor ANOVAs, where you just have one independent variable, all you're going to be able to answer with that analysis is, does that factor alone have any effect on the DV? But as soon as you're able to look at two or more factors in the same analysis through a factorial ANOVA, you can now look at interactions. And that makes it all the more interesting. So not only with a two-way, not only are you killing two birds with one stone, that is, you can save time and money by looking at hemispheric dominance and marijuana in the same study. You don't have to do separate studies. So that's an advantage. But the real advantage comes from being able to look for interactions between your factors. So in this particular setup, we are looking at a two-way independent ANOVA as far as our analysis goes. Again, it's because we have two factors, marijuana and HD. And if we look at, let's say we look at HD first, we have left and right. Okay, these are our two groups. There could have been a third because some people don't show any dominance. But for this study, we just have left and right. And keep in mind that S here stands for your particular subject. So if we were to ask ourselves who is being tested in the left group, we would see that it's subjects 1 through 15. Okay, so that's faster than putting individual names, right? So we just have 1 through 15 in the left group. And who is in the right group? A different group of people, 16 through 30. So we now know that hemispheric dominance is between subjects because the people in the left group are not the same people in the right group. If we look at marijuana, we are now looking across. All right, so we're looking at rows. Here we were looking at columns. So we have a left column and a right column. Now we're looking at rows. So who is in the none group? In other words, row 1. Well, we have 1 through 5, 16 through 20. Okay, keep that in mind. Who is being tested in the one joint group? 6 through 10, 21 through 25. So you see how the people in this row are not the same group of people as this row. And if we check the third row in the two joint group, we also see that we have an entirely different set of people. So that means that marijuana is also between subjects. All right, so because HD is between subjects and marijuana is between subjects, and there's no mention of pairing or matching, this is a two-way independent ANOVA. Okay? Now, what we're going to be able to do with this ANOVA is we're going to be able to look at the main effect of each factor. So you might recall from the lab, if we're looking at a main effect, then we're isolating each factor And we're saying, does that factor alone have any effect on the dependent variable? So in this case, does it have any effect on on creativity? So main effect of HD then would be asking, or comparing, I should say, the mean for all the lefties to the mean for all the righties. Okay, so we're going to look at their creativity score here, the mean score here, and the mean here, and we're going to compare them with that F value. That would be the main effect of hemispheric dominance. And then we're going to be able to answer the question, is there a main effect of marijuana? So what this means is we're looking at the effect of marijuana alone, all by itself on creativity. And to do that, we're going to compare the mean creativity score for everybody in the none group, everybody in the one group, and everybody in the two joint group. So we're going to have 3 means to compare. All right. Do you remember from the lab, what are these means called? These are called marginal means. So if we want to look at the main effect of marijuana and ask, does marijuana alone have any effect on creativity? We are going to compare the marginal means for marijuana. If we want to look at the main effect of hemispheric dominance, we're going to look at the marginal means for hemispheric dominance, left versus right. What about the interaction effect, the combined effect of HD and marijuana? For that, we're going to look at the cell means, okay? And here we'll have 6 cell means. All right, well, that's all we have time for today. So just, we'll go over this again in the next lecture and we'll extend it. I'll fill in all the gaps and everything, but this is, again, just a quick introduction to the two-way ANOVA. And one other thing I want to say before we close out, it doesn't matter which factor we put where. So here we had HD represented by columns, left and right. Marijuana was represented by 3 different rows. But if there was no reason for doing that other than that's what my brain told me to do. I could have put HD here, in which case we would have had 1 row for the left hemispheric people and another row for the right. So we would only have 2 rows. And if we move marijuana up here, we would have had 3 columns, 1 for the 0, 1 for the 1 joint, and 1 for the 2 joints. So we go back. Okay? So it's completely up to you which variable, which factor you want to put on as the rows and which one you want to put as the columns. And that's it.